Battery charged?
Yeah,
Ooh, right.
tis. So I brought my own sun. So, this is a solar compass. And I got the idea to do this a couple of years ago, back when NASA, Sample Robotic Retrieval Challenge thing was all the rage. You couldn't use GPS, you couldn't use a magnetometer, a magnetic compass to navigate. So you had to come up with different ways of navigating. So I actually built this top piece here, this blue board with the nylon standoff and these light-dependent resistors about 2.5 years ago, and then it kind of sat in a box after that. So I finally decided to resurrect this after having some trouble with the IMU in the Robo Magellan event at the Botanic. I thought maybe I can resurrect this and use this for navigation.
Okay.
So the basic side of this is it's got this nylon standoff and 8 photosensitive resistors, and depending which way the sun's pointing, you get a shadow on one of the sensors, and you can. I've got a voltage divider set up for each sensor, so you can just measure the analog voltage and figure out which one is in the shade and which way the sun is from there. And that's really basically it. I did spend some time working on this a little bit and thought about a couple of things, and one of the things I realized is the shadow from this nylon thing is big enough that as you're turning, the shadow comes around, it actually is like partially on two sensors
so
at one point.
You can get in between.
Yeah, so if you can interpolate that
Yeah.
in your code, you can actually get like 1 out of 16
Right.
locations instead of 1 out of 8, which is why I'm using this Adafruit NeoPixel with 16 LEDs on it, because it's to highlight the fact that I can get a little more resolution. And then I also took it a step further, and as you're coming around, you can actually kind of catch that intermediate point where instead of it's like mostly on one sensor, but a little bit on the other sensor, so you get a couple more points in there. So I actually got 1 out of 32, so I got 32 points around the compass of resolution. But anyway, that's basically what it is, solar compass, kind of fun, cute little thing,
Do you program in like where the objects are relative to the sun? Or is that the way you would use that?
Well, the idea behind this was kind of really simple initially anyway. It's kind of like, I'm going to go out and look around for some stuff, and then I'm going to come back and drop them off or whatever. I need to come back to the starting platform. So if the sun's on my right on the way out, it better be on my left on the way back, kind of thing, And then I thought, well, you can kind of do it a little more than that. You can start figuring out, well, okay, relative to my initial heading, I'm turning left, I'm turning right, you get a crude bearing.
Okay.
And as long as you have some visual indicator to close the loop, like the home base had like a colored pole or something, you just had to get close, and your vision system could take you the rest of the way. So it didn't have to be particularly precise. So it's crude compass. Oh, and I took it out this weekend. We had some variable weather. I took it out during the sunny period. It works great. It's full sun. This big fat cloud came over my place, and I thought, I wonder how well it does. Under that big fat cloud, there's no real sun. I took it out there, and it still worked. So I'm not sure exactly why that is, but there was basically no shadows that I could see, but it was still working. So it might be sensitive to ultraviolet, perhaps, or something. I don't know. These resistors, because UV, I guess, goes through clouds. So they work out pretty well. Yeah.
You say photoresistors. Is that an alias for CDS cells, or is this something else?
Well, something else. These are. Where did I get these things? I think I got them on SparkFun, but there's just a crude, stupid little, itty-bitty little sensor, and I'm not exactly sure how they work. It's got like what looks like a little copper wire and substrate, and out in the sun the resistance drops really low. Sorry.
It probably is cadmium sulfide, so.
Oh, sounds good. Yep.
Did you experiment with silvered mirrors so you could actually get 4x your resolution?
Well, silvered mirrors. I didn't. I'm getting 4x of the. I'm getting
4x what you got there.
Well, I took 8 sensors and got 1 out of 32. So you're saying I could go to like 128?
Yeah.
Perhaps. Yeah. I have not experimented with that. Yeah. Yep.
I remember. I worked on the solar compass for the sample turnover challenge.
Yeah.
And I remember the big challenge that I faced when trying to get that up and running with the Arduino, because I wrote the Arduino code for it, was all the sensors flooded out really well, being just in direct sunlight, even when they were shadowed. There was on a 0 to 1024 analog scale, they all read up in like 970, 980, even in shadow, and like the difference was like really small. Like maybe like the two that were shadowed would be like 930 or 960 versus 980. It was just really, and maybe it's just because again I'm using like SparkFun or electronic goldmine, just plain ass CDS cells, whatever. Maybe he had something more sensitive, or maybe that.
Well, I've got a 1K pull-up, so I've got a divider with a 1K pull-up and a 3.3 volt supply.
Yeah.
And so far the range is pretty good. I probably would go to a 2K if I redid it, because I can't get real low, but I can get down into like the 500 range on
somebody gave me the board, and I told them I'd try to write the software for it. So I have no idea if there were like what sort of pull-ups or anything wrong.
And what I do in my code on this is I measure all the analog voltages, and then I look for the maximum, which is the one in the shade. Okay. So it sort of adapts to whatever the overall lighting.
This is a testament to never do with $20 what you can do with a couple $1,000 on this thing. So this thing is a big bag of sensors in it on here. So and if people wanted to, I might consider pulling these screws off and showing you the guts of this thing. But it has 4 computers driving this thing. It has 2 upboards on the front side. They're running around 2 gigahertz and 8K or 8 megabytes or gigabytes of memory on them. They both have disk backing them. There's a TX2 on the front here. It's running the RTAB mapping software. Anyone's familiar with that? On the back side, there's Jetson Nano on this thing. The recent additions to these things are these 2 cameras. But on top, here's a Nito LiDAR. There's which I have to say, I've gone through 5 LiDARs. The Nito is the only one that has lasted so far and produces frictionless readings on this thing. It just works. There's a Raspberry Pi camera up here that I was using for fiducial mapping. This is a global shutter camera, which if you're going to try to do anything while your robot's moving, global shutter makes a huge difference. On the back here, these 3 things open up, and they're HDMI and USB connectors to 3 of the 4 computers in there. The 4th that was added after I built that thing there. These are wheel locks. These are the fuses to the thing. There's a big power meter up here. Gives me the battery voltage, power, current, watt hours and things like that out of here. And one of these is telling me the volts amps going through the compute elements, and the other one's through the motor elements on this thing. I left the plate off here so people can just see the rat's nest that's in here. Emergency switch on this thing here. The motors that I have on this thing, I was using Pololo motors, and I have to say I am very, very disappointed in Pololo. I've burned out, I think, 4 of their motors so far, and I've talked to them in a bunch of email exchanges about their tendency of their motors to burn out, and they told me, oh, you're doing the calculation wrong, and all right, you calculate it, you need this. So I bought one that was more powerful than that, and Pololo motors have these little teeny tiny wires, and as soon as you stall the motor, robots run into things. You stall the motors and they're smoking on you on these things. So these motors I bought here so far, I've stalled them quite a bit, and they work a champ here. So the big new interesting thing is really these 2 cameras, and they're both pretty interesting. This bottom one is the Intel Realsense T 265. Yeah, that was just announced in January, I think. So it's called a tracking camera. So it's using it's stereo vision, optical range, and I believe it does capture the infrared range, because I think it has a modified, what do you call it, the modified light, structured light emitter on there to aid it. So if the light level is too low, I believe it uses structured light. Otherwise, it'll use just stereo processing on this thing. And I have to say, I'm pretty darn impressed with this thing.
Whose 3D camera is that? So
the 3D camera on top is also Intel. So that's the Realsense D435. There's a D435i, which includes an IMU. This one does not have the IMU. So that D435 has a pair of RGB cameras on it, and it's also doing stereo depth perception on this thing. So it's building me a 3D point cloud on this thing, and I might take a chance and see if I can get my iPhone to display video, and I'll show you sort of what the point cloud looks on this thing. So the goal of this robot, if you don't remember from the couple other times I've showed this, is the infamous fetch me a beer on this thing. So there will be on here some linear actuators cross-coupled with each other, acting as pivots. So 2 or 3 linear actuators. I've sort of spec'd out the ones I need. The idea is that it should be able to go to my refrigerator, open it up, and grab a half gallon of milk and put it on the counter. So it needs on order of 4.8 kilogram meters torque that needs to be able to do, which if you were to buy motors to do that, each joint runs about $400. If you do it with linear actuators, instead of 3 pounds or so, it'll lift about 800 pounds, and each joint costs, $50 or something like that.
You need a whole gallon?
Well, I might drink some first. Remember the demo we had a few months ago here with the soda? They just kept draining the soda until it finally worked
Yeah.
on this thing. So let me see if I can get my iPhone here. Does anyone knows how to make this work the first time?
Gonna press the local.
Okay. So do we have a lightning connector?
How'd you do the lettering on the robot?
The which?
The lettering.
Oh. Have you ever heard of Cricket? I'm
Yeah,
not-
yeah, I've heard of those things.
I'm not seeing the iPhone adapter on these things.
Yeah.
I can do
That's
a,
vinyl, right? Yeah.
I can do a finger puppet demonstration. Imagine you're here and you're looking out to the audience. It looks just like that. You can generate a 3D point cloud, and under RViz, you can spin this thing around. If you're connected with me on Facebook, you've already seen this. But you can be in the middle of the room and turn around, and you can see the couch in depth and change your point of view, look around the edge of the couch, and all that sort of thing on this. So Cricket makes this XY plotter. I've got the Cricket Maker. It's about a device this big. The Cricket Maker is a little pricey. It's about $300. But you can stick in all sorts of materials. I made a ton of Christmas gifts with it. But I stuck in vinyl, press fit vinyl on this thing, and just designed this logo just before I came over. I was going to point out that this thing, I was going to demo all sorts of things on it, but I had a friend that is in the hospital, and I went to visit him and forgot to bring my computer on the way over here. So the demo works, just trust me.
Next month, right? I guess over the years, we've had the pleasure of seeing a lot of young people grow up in this club. One of those today is celebrating a very special 18th birthday. I've had the honor of working with this guy both personally as well as professionally at Ologic, and he's one of the best guys that I know. He's brilliant, and I'm sure he's going to do great things in life. So I'd like you to help me sing happy birthday to Rohan.
Happy birthday to you. Happy birthday, dear Rohan. Happy birthday to you.
We will be serving cake in the back. Feel free to go grab a slice, and then we're going to take a 10-minute break. Okay, before we start the presentation, I just wanted to let Rohan say a few words to everybody.
So I really just wanted to thank all of you for both this birthday celebration and just everything that I've gotten from the club over the many years that I've been coming here.
George.
I think you all deserve a round of applause for yourselves for everything that you've taught me and like given me opportunities and everything, and I really appreciate it. I want to tell a story from 6 years ago. It was a homebrew robotics club meeting, the one in May, again on the 29th. So I came to the homebrew robotics club kind of late because I had my birthday dinner, and so there are some stories there involving my dad forgetting his credit card. So it took us a while to get here. So after actually finally getting to the meeting, I talked to Ryan Hickman and asked him if there was anything I could do, like internship-wise or something over the summer. And Ryan, he referred me to Ted. I don't think I saw Ted here, but Ted Larson of Robotics. And Ted offered me my first internship right there. So that was kind of the best birthday present I could ask for, is interning at a robotics company at 12, and Ted taking that chance and giving me that opportunity. And then I think this year I asked Ryan again if there was anything for me to do over the summer. And yeah. Again, Ryan hooked me up through Ted. Yeah. So yeah, it's just yeah, I just wanted to thank the club for all the opportunities, and I could go on and on thanking each individual member, but just yeah, thank you all, and for everything throughout the years. I think I've been coming here for almost 8 years, maybe a couple meetings before that as well, but yeah, it's really been
You remember your first robot?
yeah, the Canon Boom bot.
Canon Go Boom.
Yeah. Camp PB helped me build that. So yeah, anyway, thank you all, and I'll let the rest of the presentation start now. Now, my voicemail, as
I don't let it change.
Yeah.
I like it.
yeah, it's from when I was 8. So if you call me and you get to voicemail, you'll hear me when I was 8. So that's probably when I started coming to these meetings.
Well, it's been great having you around, Rohan, and
Thank
I
you.
hope that you continue being active with the club no matter where you go.
Okay, thank you.
Thanks.